Algebra and trig review. All right, what kind of algebra do you need to be able to do for calculus? Any guesses? What kind of things do you need to be able to do? Factor is an important one. All right, so let's start with factoring. Factor. Oh, we'll start with an easy one. How about x squared minus 3x minus 21. No, that's not going to work. 28. 28. What does it mean to factor? Break it down how? Into its smallest components. Okay, so we break it into prime factors. But what do factors mean? Tell me what the answer is. I'm sure that's easier. What's the answer look like?
Wait, are you asking what the answer is?
Yeah, what's the answer?
X minus 4, x plus 7.
How about x minus 7, x plus 4? So how did we write that? What does it mean to factor? We wrote that as a multiplication of two binomials. So to factor means to write things using multiplication. That's all it means. If I asked you just to factor that, I'm sure all of you could factor it, but you didn't know how to explain to say I want to write it using multiplication. So that's what factoring means. All right, so that was an easy one. How about this one? Factor 4 times x plus 3 squared times x minus 5 to the third plus 6 times x plus 3 cubed times x minus 5 squared. Now you're thinking he made up a hard one just to make up a hard one. Well, that's not true. In the not too distant future, we're going to talk about something called derivatives. And when we take derivatives, we're very often going to end up with answers that look like that. And what we're going to need to do next is set them equal to 0 and solve them. In order to do that, you really need to factor them. How do you factor that? Any ideas? Go ahead.
Well, first you got to combine everything.
All right, that's one way to go. That's the hard way.
Or you could, split it into two and separate the factors. So it'd be like 10 plus.
Well, you're close. I can't really combine these and call it 6 plus 4 is 10 because these have different powers. This one's got a 2, that one's got a 3. So I can't add them. They're not like terms, unfortunately. What a lot of students will do is they'll take x plus 3 and they'll expand it out. They'll do FOIL. They'll take x minus 5 and cube it out and do FOIL and then try to factor from there. That will work, but it's very, very difficult. There's a much easier way. All right, let me give you an easier problem, and you tell me how to factor this one. What if I gave you, we'll come back to that one in a minute, it's 4x cubed plus 6x squared. How would you factor that one? Do what? There's a common factor of x to what power? X squared, and there's also a common number, isn't there? 2. So you would factor out the greatest common factor. The greatest common factor is 2x squared. And then what's left over? 2x plus 3. All right, now back to the hard problem. We're going to do basically the same thing. We look at the numbers. The numbers we have are 4 and 6 still. What's common with a 4 and a 6? 2. So we're going to factor out a 2. And then we notice that we have an x plus 3 squared here and an x plus 3 cubed there. So what's common to an x plus 3 squared and an x plus 3 cubed? So our greatest common factor there is x plus 3 squared. And then finally, same thing with those, right? What's common on that one? X minus 5 squared. All right, and then I like to draw a big bracket. What's left over? Well, I had a 4. I factored out a 2, so left over is a 2. I had an x plus 3 squared, but I factored that completely out, didn't I? So how many x plus 3 pieces are left? None. I had x minus 5 cubed. I factored out 2 of them, so how many are left? 1. So I'm going to have an x minus 5 plus. And then I go to the other term. Here's a 6, but I factored out the 2, so left over is a 3. And then what else is left over in this term? X plus 3. All right, then our final answer, we would have the 2, x plus 3 squared, x minus 5 squared, and then we would go ahead and just simplify what's inside those big brackets. And I would kind of hope you could do this in your head. 2x and 3x is going to make 5x. And then I'm going to have a minus 10 and a plus 9. A minus 10 and a plus 9 is minus 1. So there would be my answer factored. Why do we want to factor? How would that help us solve that equation if we made that equal 0? So now how would you solve? We got this in the factored form here. 2 times x plus 3 squared times x minus 5 squared times 5x minus 1 equals 0. And this is really the main reason we teach factoring, is for solving equations. How do you solve that equation?
Get x by itself.
You want to get x by itself, and what do you do with each of the factors? Set each factor individually equal to 0. So we would take x plus 3 squared equals 0, x minus 5 squared equals 0, 5x minus 1 equals 0. What's the answer for the first one? X is 3? How about negative 3? Why negative 3? Because negative 3 plus 3 gives you 0. Does that square really make any difference at all? No, not at all. All you need really is 0 in the middle. So x equals negative 3. The second one, x is 5. And the last one, x is 1/5. Questions on that? What's that?
It's coming back.
It's coming back? Yeah, unfortunately, I find in a lot of pre-calculus classes, we don't spend a lot of time factoring that kind of thing, which is unfortunate because that's what you need in calculus. Sometimes pre-calculus doesn't really do that great of a job of getting you ready for calculus. All right, here's another one. See if I can make one up. It's even harder. How about simplify? X minus 2 to the 1/3 times, we won't go too bad, x squared maybe, minus 1/3 times x minus 2 to the negative 2/3 times x cubed. And by simplify, I really mean factor again, is what I would really want you to do there. What do you do? Any ideas?
Let's do the same thing.
You want to do exactly the same thing. That's right. You want to factor out the common terms. So what do you have for common terms? All right, so there's definitely an x minus 2 in each one, isn't there? There's an x minus 2 there and an x minus 2 there. But what power do you pick? Which one? All right, well, just for a minute, let's pretend that instead of a 1/3, let's pretend that one was a 3. And instead of the minus 2/3, let's pretend that one was a 5. If this power were a 3 and this one were a 5, which one would you factor out? The 3. How come? It's the smaller one. Back up here, when we had a squared and a cubed, which one did we factor out? The square. It was a smaller power. So you got to look at these two powers. We have a 1/3 and we have a negative 2/3. Which one do you pick? The negative 2/3. You always factor out the smaller of the two powers. All right, so we're going to factor out x minus 2 to the negative 2/3. And do we have any other common terms? X squared. That one's the easy one, right? Because we have x squared and x cubed, we factor out the x squared. All right, now comes the hard stuff. We started with an x minus 2 to the 1/3, and we factored out an x minus 2 to the negative 2/3. So how many x minus 2's are left? Excellent. You subtract the power. Again, back up here, we took out an x plus 2 squared, and on this term over here, we had 3 of them. 3 minus 2 gave us 1 left over. It's the same trick here. You subtract the power. So you're going to take 1/3, and you took out negative 2/3. What's 1/3 minus negative 2/3? It's 1. So we have x minus 2 left over, just to emphasize it, to the 1. And then what about the x squareds? We factor all of them out, didn't we? Because we had x squared, factored out x squared. Minus 1/3. How many x minus 2's are left over? None, because we factored them all out, because we factored out negative 2/3. And then we'd have an x. All right, so final answer, we would write x minus 2 to the negative 2/3 times x squared times x minus 2 minus 1/3 x. What's x minus 2 minus 1/3 x? Nope, no x squares. What's x minus 1/3 x? 2/3 x. So that's 2/3 x minus 2. Once again, now I want you to solve. Solve x minus 2 to the negative 2/3 times x squared times 2/3 x minus 2 equals 0. What do you get for answers? Go ahead, James.
2, 0, and
Yeah, that's the hard one, isn't it?
6 halves.
6 halves, which is a fancy way of saying 3.
Sorry.
6 halves is correct. It's just easier to write it as 3. I almost agree with you. One of those 3 answers is wrong. The first one is wrong. How come? You don't know.
Oh, it's 1/2.
Nope, it's not 1/2.
No, wait. You have to flip it, and then it's 1 over x minus 2 to the 2/3. And then in order to set that equals 0. So, well, that's a big one. I can't do that.
You can't do that. Okay,
I'm
good.
doing it on my paper.
So we'll just cross that one off. We can't do it. What's wrong with that one? You said what's wrong, actually. What does a negative power do? Flips it, puts it in the denominator, doesn't it? So x minus 2 to the negative 2/3 is really the same as 1 over x minus 2 to the 2/3. What's that? And I can't divide by 0. So 2 looks like it's the right answer there, but it's not, because that negative power really drops that thing down to the bottom and you can't divide by 0. So that's a tricky one that people will forget about. So when you have negative exponents, the negatives do matter. It means you're not going to have answers. Makes it much easier. But a lot of people would forget that, and they would write x equals 2 there. So be careful on that one. Questions on that? All right, here's a few other things you need to be able to do in calculus. Determine the equation of the line through. Somebody give me 2 nice points. Anybody have 2 nice points?
1, 2, 2,
1, 2. Let's not use 2 and 1 because it makes things too symmetrical.
1. 3, 4.
3, 4. Not very exciting numbers, but we'll do it. All right, so we have the point 1, 2 and the point 3, 4. If I give you 2 points, how do you find the equation of the line? What do you need to know? You need to know the slope. Anytime I mention a line, you better know the slope. How do you find the slope of a line? Rise over run. That's correct. Anybody got a little formula for slope? What's that? Changes in y's over change in x. All right, so quite often the formula for slope is written as y2 minus y1 over x2 minus x1. Rise over run. In this case, what's y2 minus y1? 4 minus 2, which is 2, over, what's x2 minus x1? 3 minus 1, which is also 2. 2 over 2 is 1. All right, so we know the slope. Now, how do we find the equation of the line? Do what? All right, we have 2 choices. We can use y equals mx plus b. That's one option, and we'll do it that way. And then there's a second option. Anybody know the other option? Put it into your calculator? Yes, there is a way to do it using your calculator. That's true too.
Y minus y1 equals
You're right. Keep going. M times. That's correct. Y minus y1 equals m times x minus x1. Those are your 2 choices. The first formula has a name. What's the first formula called? Slope, intercept. M is the slope, B is the intercept. This one is exceptionally useful if you know the slope and you know the y-intercept. What's the second formula called? M is still the slope. And what's x1, y1? It's a point. So this is called the point slope formula. All right, so let's use y equals mx plus b first. I find that's the way most students like to do this problem. Do we know the y-intercept? No. How do you know we don't know the y-intercept? That's right. To have the y-intercept, we would need 0, comma something. We don't have that. But we can still use this formula. And what you do is you write y equals 1x plus b, because the slope is 1. And then how do you find the value of b? Substitute one of the points in. Which one? It doesn't matter. You pick one that you like. I'm going to use the first one just because I like the first one. 2 equals 1 times 1 plus b. So b is 1. 2 minus 1 is 1. So our answer would be y equals x plus 1. There's our answer. The other option is to use the formula on the right. That's the formula I prefer, especially if my slope is a fraction, because if my slope is a fraction, solving this over here can get a little ugly. So here I take y minus, what's my y1 number? It could be 2 or 4. You can use either point. I'm going to use 2 again. Equals m. M was 1 times x minus 1. And as far as I'm concerned, that's a perfectly 100% correct answer. I didn't see any directions that told me I had to simplify it or put it in slope-intercept form. That's fine by me. If you want to leave your answer just like that, I'll accept it just like that. Like I say, I prefer that way because most of the problems we're going to do, our slope is not going to come out to be a nice number like the number 1. It's going to come out to be some sort of fraction. And if I don't have to simplify, then leaving it that way is fine. I don't have to do any arithmetic. I don't have to mess with the fractions at all. Questions about that? All right. How about this problem? F of x is x squared minus 3x. G of x is 4x minus 2. Find this thing. Oh, give me a number. Anybody got a number? 3. So I want to know that. Oops. And then I want to know that. So I hope those are symbols you've seen before. What's that symbol called? Anybody remember? Composition. That's called function composition. What does that symbol mean? What does FOG at 3 mean to do? It means f of g of 3. Okay. So what do I do?
Solve G3 and then solve F for the answer.
Exactly. What this symbol means is, this symbol means start with the number 3 and plug it into the G formula first. So what do you get when you plug 3 into the G formula? 10. And then I take that answer and I plug it into the F formula. What do I get when I plug 10 into the F formula? 70. So the answer would be 70. What does GOF, and then I didn't give you a number, I just put an X there. What does that mean to do? That doesn't mean solve for X. We're going to simplify when we get done, but what are we going to do? Right. What this really means now, it just means take the F formula, take the whole formula, because I just left the X there. Take the whole formula and plug it in wherever you see an X in the G formula. So what would I end up with? I'd have 4. X, I would have x squared minus 3x, and then I still have that minus 2 on the end. Again, I'm not a big fan of forcing students to simplify, so I would accept that answer just like that. But this one's easy enough, I kind of hope you would simplify it. I mean, I would hope you would write 4x squared minus 12x minus 2, but if you didn't, I wouldn't take off for it. Questions about that one? H of x is 2x minus 3 to the 8th. Find f of x and g of x so that h of x is f composed with g of x. So now I'm kind of going backward. So in the previous problem, this might have been h of x, and I gave you f and g. Now I'm doing it backward. I'm giving you h, and you have to tell me what f and g started as. And this will be a very important skill when we get to something called the chain rule for derivatives, whatever that means. There are an infinite number of correct answers. So you should be able to come up with at least one. And there's one answer that's a lot more important than all the others, but there are an infinite number of correct answers. Anybody got an answer? F of x could be, and g of x could be x to the 8th. Which one, F or G? F is x to the 8th, and G is 2x minus 3, I think. Because if I asked you to do FOG now, what would you do? You would start with the G, 2x minus 3, and you would plug it in for that x. And you would end up with 2x minus 3 to the 8th. That is a correct answer, and that is the important correct answer when we get to something called the chain rule. But as long as there are other correct answers, can anybody give me a different correct answer? You were very close. X to the 4th is correct.
You have to do 2x minus 3
to the second. Very good. Because now when I plug this in, when I do a power followed by another power, I multiply my powers. 2 times 4 would give me 8.
It's only when they're next to each other that you add, right?
Correct.
Yeah.
Only when they're next to each other do you add. That's a correct answer. Why do you think that one's not as good as the first one?
It's not very simple.
Yeah, in a sense, these two pieces are as simple as they can get. 2x minus 3 is just a linear term. X to the 8th is just an exponential term. So while this is correct, this 2x minus 3 squared is something we don't really like. This wouldn't help us when we get to the chain rule. But it is a correct answer. Anybody have any other correct answers?
You could make f of x, x, or g of x, 2x minus 3 to the 8.
Yep, that's the stupid answer. F of x is x, and g of x is 2x minus 3 to the 8th. Or you could reverse those two, and that still works. That's another correct answer. But that one doesn't do you any good at all, because you really haven't simplified this piece in any way, shape, or form. So again, that's a correct answer. And there are an infinite number of correct answers, as long as when you take this power and that power, they multiply to be 8. So this one could be negative 4, and that one could be negative 2. And it would still work when you plug it in, because negative 4 times negative 2 would give you 8. So there are lots and lots and lots of correct answers you could come up with there. Questions on that? All right, so we will deal with function composition. Oh, let's try a little trigonometry. How about, what kind of trigonometry do we want to do? Solve. Let's solve an equation. Solve sine of x minus pi over 3 equals 0. What do you notice right away about that equation? It's in radians. That's correct. How do you know it's in radians? Because I gave you a pi over 3, and it doesn't have a degree symbol on it. In calculus, we will always use radians. We will never, ever, ever use degrees. Why not? That's correct. It's not that math teachers are mean and like to force you to use radians, which is true too, by the way. We are mean. We do like to force you to use radians. But we will find that something called derivatives only work well if you're dealing in radians. So we will always use the radians. We will never, ever, ever use degrees. All right. How do you solve that equation? Go ahead.
You figure out what the sine of pi over 3 is equal to what degree, and then you figure out which degree has equals 0. So just work backwards.
That's what a lot of students would do. A lot of students would convert to degrees, work in degrees, and then when they get done, they convert back. Hopefully, by the end of the semester, you won't do that anymore. It takes too long.
You don't actually have to convert it into degrees. Like pi over 3 is obviously 60, but if you took it...
30?
Sorry. Excuse me. Pi over
60?
3 is 30. And
60?
What?
See how easy it is to talk people out of things? You were correct the first time. It is 60.
Thank you.
You're welcome.
Thank you. Anyway, all you have to be able to do is say what you have to move it to get to 360.
All right, very good. So what we really need to know, let's start with a little bit easier equation. So, sine of theta equals 0. Let's forget that we got x minus pi over 3 for a minute here. Sine of theta equals 0. What values for sine, what values for theta give you 0 when you're dealing with sine? 2 pi and pi and 0 and 360 if you're working with degrees. So theta could be 0. And then we usually write something like this. Plus and minus 2 pi k. What the heck is that?
Means it can be either like whatever you add 2 pi or any number of 2 pi's.
Right. So 0 works, but 2 pi also works. And 2 pi is what we call a coterminal angle. If you draw 0 radians and you draw 2 pi radians, they look exactly the same. 4 pi, 6 pi, 8 pi are all coterminal to 0.
Just put 2 pi k. You have to put 0 there.
You could just put 2 pi k. That would be correct too. And then what's the other place? Theta could be, what's the other spot where sine is 0? You already said it.
180 plus minus 2 pi.
Which we're going to write as pi. 180 degrees is correct. We're going to write it as pi because we're always going to use radians. Plus and minus 2 pi k. So there are really two answers. There's 0 and there's pi, and then there's everything coterminal. But how does it switch when instead of having theta, we have x minus pi over 3? Well, it really doesn't change very much. we have to have x minus pi over 3 equals 0 plus or minus 2 pi k. And then how do we get the x all by itself? Add pi over 3. So x is pi over 3 plus or minus 2 pi k. And then same thing over here. X minus pi over 3 is pi plus or minus 2 pi k.
So if we solve an open-ended question like that, you like the infinite form?
Generally, I ask for all solutions. If you left off the plus and minus 2 pi k, I wouldn't be real upset. But generally, I want all solutions. How do you get x all by itself there? Add pi over 3. What's pi plus pi over 3? 4 pi over 3. So x is 4 pi over 3 plus or minus 2 pi k. Questions on that?